Good morning, everybody. So we've done quite a bit of work with some more abstract-ish concepts, more kind of complicated concepts with the addition postulates. So why don't we dial it back a bit and just focus on something a little more strictly mathematic, something that we can just use a calculator for a lot of it. And it doesn't take much more than that. So today we're going to be looking at the distance formula. We talked a little bit about distance. Oh, this pen is already running dry. We talked a bit about distance when we talked about line segments, but that was actually a two-dimensional, or rather a one-dimensional distance. Kind of like if you take a ruler and measure along a flat line. Now we're going to be applying distance to a two-dimensional plane, also known as the Cartesian plane or the coordinate plane. This is like the grid you see when you look at graph paper. So whenever you're dealing with something that looks a little more like this, we're dealing with a Cartesian plane. Let's see if I can get a little bit more out of this pen. Oh no. I think that's it for this pen. Let me write over that. So we're going to be looking at the distance formula. There we go. Flipping ahead to page 11. Going through the motions, titling it. And you know what I just realized? I don't have my notes. There we go. Now I have something to reference. So we're going to start off with the distance formula. Is used to find the distance between 2 points on a coordinate plane. We say the distance between points x1, y1. So that's x with a little 1 in the subscript. And x sub 2, y2 is calculated by d equals the square root, and I'm going to take that root really long out because we have a lot to fit under here. x2 minus x1 squared plus y2 minus y1 squared. So that formula is going to be our guide for everything we do with distance. It might look a little bit intimidating at first. There is a lot of different symbols, subscripts, superscripts going on. But if you take it one step at a time, it's really not that intimidating. So we really, in math, just really got to take things one step at a time. That's the biggest, most important thing that you do in math. So let's take a look at some examples. So for this first example, we are going to find the distance between -5, 3, and -2, -3. So just a quick side note while I'm thinking about it. When we did two-dimensional distance, we would have a number line and 2 points on it, say 1 and 6. And if I asked you the distance, we could just count 1, 2, 3, 4, 5. I forgot one. There we go. And we would know that our distance between 1 and 6 is 5. But now what we're dealing with is a two-dimensional coordinate plane where we have points that aren't sitting on the same quite line together. And when we're asking about the distance between these 2 points, it's no longer on a line that we can easily just count one square at a time. I can't go 1, 2, because it isn't quite how this works. And that's why we have to use this crazy formula. And what we're doing with that formula is we're figuring out the change in the x values and the change in the y values. And we're using a little something we're going to study in the future called the Pythagorean theorem. But more about that later. So essentially, the reason we're using this big complicated formula is because these points are no longer on a line that we can simply just count the jumps between. So there's some important steps for each. We want to choose a label for each point. It's very important to know which point you're treating as your ones and which one you're treating as your twos. What I mean by that is I usually just take whatever the first point they gave me was, and I call that my x1, y1. So now I know x1 is -5, y1 is 3. And then over here, the -2, -3, I'll make those my twos. x2, y2. It doesn't matter if I had switched it and called these my twos and these my ones. As long as you keep your ones in the same set of parentheses and your twos in the same set. That is so important. Then the next step will be to plug into the formula. So now that I know what my ones and my twos are, I can substitute them into the formula. So I know that D equals big square root, and I'm going to be looking up here. So I'm going to start my parenthesis, then x2. While looking here, x2 is -2. So I'm going to put -2. And then that's minus x1. Well, my x1 is a -5. So we're going to have minus a -5. And then I close the parenthesis and I put a square. Moving along, we have a plus, parenthesis, y2, that's -3, minus y1, which is +3. And that's all squared. So all I did is I went through and I did x2 minus x1 plus y2 minus y1. Again, this may look intimidating, but we're going to break it down step by step. So first, we're going to simplify the parentheses. So all I have to do, ignore everything else. And I'm just going to look, what is -2 minus -5? Now you are absolutely welcome to use a calculator for all of these steps. And I have this fancy expensive one, but literally your phone calculator will work just as well. I can put in -2 minus -5. And that'll give me a +3. That's the same as -2 plus 5 due to that double negative. So we took all of that, simplified it down to 3. I'm going to keep it in the parentheses though, because if it was negative, I want to keep that negative sign in the parentheses because it'll affect how that square works. And we're adding to -3 minus 3. Again, you can use your calculator. -3 minus 3 is -6. Again, I want to keep that in the parentheses because that'll change what number I get when I square it. All right, we're already looking a bit better here, not quite as much going on. I put 1, 2, 1. My bad, guys. This should be step 3 because then step 4 is to square each value. So square the values. So for this, I'm going to do 3 squared and -6 squared. So again, you're absolutely welcome to use a calculator. 3 to the power of 2 is 9. And then important, parentheses. When you have a negative number, you need those parentheses. -6 squared is 36. This is important because if I put -6 squared without any parentheses, I would get -36 because it's doing -1 times 6 squared. In the order of operations, say they have to square it before they can apply that negative. So make sure you're putting those parentheses around your negative numbers. You can put them around the positive as well. It's just one extra step. Okay, so 3 squared was 9. I no longer need the parentheses. And -6 squared is 36. And then I feel like it's pretty obvious from here that we need to add. So 9 plus 36 is 45. And now some people prefer to leave their answer like this because it's the most exact form. There's no decimals. So the square root of 45 could be your answer. We're going to take it one step further, and we're actually going to do the square root. Now, in a calculator, if you have a scientific one, you can absolutely do that. So on one of these, the square root button is found up here, but I really doubt most of you have one of these calculators at home. So we're actually going to take a look at all right. I'm going to go to, if I could see it, it's hiding my tabs. Go away. This one? Yes. Okay. So this is a free online calculator, and I absolutely adore it. It's called Desmos. Just go to desmos.com, and you'll find the calculator. And in this box right here, it'll pull up a math like calculator at the bottom, and I can hit the square root key right here, and then type in my number 45, and it'll show me what the square root of 45 is right there, just like a calculator. So then I go back. Pew. here, and I know that that was equal to, I can't have both up at the same time. I put the square root, that's my bad. 6.7082, blah, 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 blah. So we're gonna round that because I don't wanna write decimals for the rest of my life. We'll round it to 2 decimal places. So 7 and then 0, but the 8 rounds it up. So remember, if that third number is greater than 4, so 5, 6, 7, 8, or 9, then that number goes up 1 value. So we'll have 6.71. All right, so I'll do another example. And then I'll show you guys a fantastic trick. So we're going to find AB, which would be the distance of the line, when A is -4, 1, and B is 3, -1. So find AB means find distance. It's an important note to make. So we want to tell ourselves, what's my x1, y1, what's my x2, y2. Again, I just go in the order they give it to me. So A is the first point they give me. I'll make this x1, y1. B is the second, x2, y2. Remember, your 1s are together and your 2s are together originally. That only changes when it's in the formula. So I'm going to write out my formula and substitute in. So I'm going to look at the formula at the top of the page. So we have x2, that would be 3, minus x1, -4, plus y2, -1, minus y1, +1, squared. There it all is in its glory. And we're going to take it one step at a time. So first, I'm going to simplify what's in the parentheses by subtracting. So 3 minus -4 becomes 3 plus 4, and that's 7. -1 minus 1 will give me -2. Then I square it. 7 times 7 is 49. And 2 times 2, or -2 times -2, is +4. Now I add those two numbers together. And I get 53. And then if I take the square root of 53, again, it's going to give me a big, long, nasty number, but that's okay. I get 7.28011 ... So I'm going to round that to 7.28. The third number is less than 5, so I don't need to round up. I just have 7.28. On your homework, I'm going to be looking for your answers to be rounded like this. Okay, now here's the big kick, the big trick that I was going to show you guys. You can plug the entire formula into some calculators. Now, what I mean by that is instead of going through every step one by one and solving it by hand, you can have your calculator do the whole thing. So in class, we have these TI Inspires. You absolutely do not need to buy one at home. But the TI Inspires are so advanced that I can start my square root and I can type in everything exactly as I see it. So I'm going to do this one. 3 minus negative 4 and parenthesis square plus parenthesis negative 1 minus 1 and parenthesis squared.
Welcome to Wet Wednesday.
Sorry about that, there was an announcement. Okay, we finished it off. Everything is matching up with how it looks here. If I hit enter, boom, there it is. The exact same answer that we found by doing it the long way. Now, I appreciate knowing how to do each step because I appreciate the mathematical process and it's good for our brains to practice it. But this sure does save a lot of time. Now, for y'all at home who don't have that, I'm going to share my screen again and we're going to look at Desmos. So I'm going to do the same thing I did on that fancy calculator, but here. I'm going to start by hitting the square root, and I'm going to type everything as I see it. Parenthesis, 3 minus negative 4, and parenthesis. And then I can hit this to square it. Or you could use the caret too. I'm going to hit the arrow key because right now it's on the exponent. So I'm going to hit the arrow key, do plus, parenthesis, negative 1 minus 1, and parenthesis, square. And there you have it. You just want to look at this and make sure that it's matching what you wrote. You want to make sure that the square root is extending all the way out on top. If it's not going to square root the whole thing like it should. That's part of why I think it's important to know the process by hand, because otherwise you won't really quite understand if your formula doesn't work out. But again, we can see here that we got 7.28011 ... So you're absolutely welcome to use a calculator like this in class and just put the entire problem in here. Doesn't matter what your numbers are, 11 minus negative 7 squared plus 3 minus negative 2 squared. You can put any single distance formula you come across in here and see how much faster that is. That's why I show you guys. It can save you a lot of time. And this is probably showing up for us too. I tell that to go away. All right, so that's all I have for you guys with distance formula. We're just learning how to use that formula today. So it's very mathematical. A calculator can help give you all the answers as long as you're putting it in right. All right, so good luck to you all, and I will see you tomorrow when we talk about midpoint.